Thank
So
you.
over to our next presentation, Fabio from PIPA, and he's going to be talking about in-pipe leak detection and leakage solutions. So Fabio, over to you.
Okay, can you hear me?
Yes, we can, Fabio, and we can see your slides.
My name is Fabio Orlandi, everyone. I'm the commercial director of API and PIPA Limited. So basically, API is our service company that offers global surveys on water mains, and also the trainer for PIPA technology. PIPA specialises in pipe inspection technology and leak detection tools for global markets now. So everything I'm presenting today is not a prototype of these commercially available tools we've used over the past 12 years. So working out the UK markets, it's been a great playground for us because they're very stringent on health and safety, hygiene in water, especially drinking water, and we've approved everything for safe use of potable networks. So technology we have today covers all size pipes. So we worked on service pipes up to a very large diameter trunk mains, and more recently our biggest market seems to be the new pipe installations. So traditional technology on the marketplace today for leak detection, well, you know, there's limited factors, that whether using correlation, loggers, tracer gases, they're all got the place in the toolbox, but there's also factors external to this, you know, whether it's ground conditions, location, external sounds. So we've gone to the markets. Everything we do is basically specialised in pipe inspection. So you can work in all materials, all pipe sizes. You'll find in the leak as it exits the pipe, you know, it's sort of in the pipe and showing where it's going to be. So this is a real study here where top sounding of a leak is not always present on non-metallic pipes especially, and water always finds its own path. So this job here we're showing on the screen was the hydrocam was used, our insertion tool, where the leak was 22 meters from where the water was showing. So, you know, it's not always a top sound approach is the way forward. So being inside the pipe with technology, you are passing the actual leakage point. So all of our platform tools on the marketplace are basically inserted into the pipe. They're basically external, it's internally done, live audio out of the system. Everything's sanitized and chlorinated to the network. It's all basically traceable as well. So we'll talk about mapping pipes, so you can trace these technologies. A bit of a case study or project now we're involved with heavily in the UK is Welsh Water. They're the first UK company to look at zonal studies of the network. So they're looking at every single asset on the network to prioritize where they spend their money. So whether it's basically is a pipe lined, unlined, clean or dirty, confirmed size and material. All this data is vital for planning your next step in the rehabilitation of pipe networks. So other services there on the network is some illegal connections for project overseas. And, you know, reasons why I use technology, well, there's numerous reasons where it's knowing what's down there from GS, looking at buried valves, leak detection, checking materials, blockages, closed valves. There's numerous reasons this technology is really vital before you start digging and cause excavation headaches. So into the bigger size pipes, floating system, this is the flow rider. So it's inserted into the pipeline similar to other products, but it's a combined camera, acoustics and traceable system. We've also modified this unit now to be a collapsible chute, so you can float down 1,000 meters in high or low flow rates now, collapse the chute remotely and pull the sensor back. So that's a massive advancement into technology today. Flow riders are one insertion point, small footprint, so small chamber required at ground level, so like a through-bore hydrant or direct tapping. Basically, it's all battery powered, so silent operation, remote operation. This can be used anywhere in the world, you know, with no external power required. Then it's the bigger system we've got now for large mains is the Pluto. This is a tethered device again for inspections of large diameter pipes. We made it a 2-kilometer system from the start. However, last year the first project we won with this system was in Hong Kong, and it was a 4.3-kilometer survey, so we can do further distances. The bonus of this technology is you've got the camera system, the acoustics, and the actual extra lighting, but also telemetry there. We've added to it temperature sensors, pressure sensors as well, so you can basically do a nice graph to show the client peaks and troughs in pressure on a pipeline, and also check the temperature of the water throughout the survey. So a lot of data on there and some images there of the actual system there. So basically you insert live into a network, you float down a chute downstream, you extract it live and then pull a sensor through the network. New main leak detection, this is the pipe pod hydrostatic. So this is made for up to 2 kilometers around as many bends as you like to basically be a fail-safe on all new pipe installations. Believe it or not, new pipes are failing every day, and the delays and cost is absolutely astronomical. So basically, this is inserted into the pipeline with a swab as part of the build process, and then cleaning process, and the sensor is pulled through to find leaks accurately. From this, we jumped into camera surveys and new mains. So we're calling this PCI inspections, pipe commissioning inspections, to give the client the actual confidence in the quality of the installation, and also the actual checking for air pockets, debris in a pipe, make sure the pipe is up to standards. And recently we've won projects overseas where instead of swabbing a pipe to clean it on new mains, they're going to install our cable as part of the build process and build this cable within the pipeline, and then pull the camera through for inspection, chlorinate the same water, and put it into service. So the millions of gallons of water that we save now from this technology is actually huge. And then the pipe pod flow rider. So this is a floating capsule up to 5 kilometers to do a leakage sweep within a pipework. So this has gone to many countries now on drinking water mains and also riser mains. It can be used as a riser main assessment tool. The cable itself, we're now pushing as a permanent installation as well. So this system is approved for materials in contact in drinking water, and it can have a 5-year life in a pipeline. So any high-risk locations, this can be stored into a network. The software we have as well is now scanning through the data. So a year ago, 12 years of audio was listened in the office with the operator. Now the data is scanned through quickly within 30 seconds to give you points of interest. So this image shows you an actual leak found on a network. We also make water tools for the industry now. So we've made cleaning tools for hydrants. We've made injection devices for loose jumper hydrants, which is industry first again. So you can keep custom supply now with all type of fire hydrants. R&D solutions, we're talking about budgets available for R&D. Well, we're happy to collaborate with any company out there on any solution you deem necessary for the industry. New solutions we're working on now is basically, there's a few. There's a live boundary box replacement tool, which is costing people millions of pounds to replace boundary boxes when a 2-pound valve is faulty. So instead of replacing the box, we're going to replace the valves live. A live installation strainer for discoloration. So water complaints can now be solved by a temporary or a permanent installation of a straining device directly to the network. Working on a hand tool solution for the industry as well, to give you more torque and unbolting and bolting flanges on a water pipe. And also the in-pipe solution. So we've been approached by many companies now to offer a solution for in-pipe repair. So we can see the leaks, we can hear the leaks. Why not repair the leaks? Some case studies here. So this is a job in Scotland on a hydro scheme where the client was losing a lot of money every year with his hydraulic output. We did a 3.5 kilometer survey with a flow rider, and we found, as the picture on my left shows, the pipe has imploded or gone flat, and the joint is now leaking, costing a lot of money per year. This one, another one, this is a new main solution we didn't mention earlier. This was basically a job in the UK. This main failed its test for 18-month period of time, and the cost calculation was £250,000. We found the leak within half a day using our technology. So a great fail-safe on all new assets. And then the Hong Kong project with Pluto. This was a 4.3 kilometer survey, a tethered survey into this network. And basically we're saying, look at your pipelines, confirm internal condition, remove the unknown pipe issues, and then listen. So in-pipe solutions, acoustics, look at points of interest and verify points of interest. As already mentioned, most leaks on large diameter pipes happen over many, many years. You know, a pinhole leak eventually turns into a failure, and once it fails, that's where it goes from thousands into millions. So find the leaks now and then repair the leaks now using this technology. And then PIPA technology, innovation, knowledge, and training. Many thanks. Any questions?
Fabio, and I will be. Any slides you had, I actually said to someone, if he gets through all of those in time, I will eat my hat, and it looks like I now need to eat my hat. That was very impressive. Thank you. Look, I'm really, really interested in some of the stuff you've been talking about, particularly the work you've been doing on brand new pipe.
Yeah.
Because I see that as a huge issue in our industry, that we seem to be unable to lay plastic pipe that doesn't leak. Yeah. So, you know, talk us through what your solutions are doing on that, and what you're finding. Where are you finding these leaks on this brand new plastic main?
Well, we've pushed this in the UK markets. We started this about 4 years ago when a client had a failed new main, and we basically had a solution with our push system, HydroCam, and we were finding leaks. However, we were saying, well, you know, we're pushing 20 meters this way, 50 meters this way, which is all you'll get with a push system. And how long do you need to measure? And they said, well, 1 kilometer. So we made a 1 kilometer device. Great. problem we had was the first job they gave us was 2 kilometers because of behind schedule. They put 2 schemes together, so I had to redesign the cable, the seal houses, etc. So now it's standard out the box 2 kilometers. But what we find is typically the actual installation conditions. So a lot of these sites are new road, big new motorways, and the sites are such horrendous conditions with weather. And so it's the joints, basically misaligned joints, failed couplings, even down to design issues. You know, it could be like a thrust pot required where it's not been installed.
And you showed that slide quickly, and I think I'm going to have to go back and look through your slides to see this one more. But this right. What I'm going to call a smart swap. This idea of you have a cable, they lay a cable and put it through. So talk us through how that works. You've got like 2 minutes, but just talk us through how that works. Is that able to find a leak that's actually
so basically the system was made at the start. We put building the cable within the pipeline, and then every water company since then says we don't want that. We want to do this, build the pipe, and then swap the main as they do to clean the pipe, and then do the testing. So we went on that approach. We give you the cable, we give you the seal housing, and you do that installation. The issue then was, well, you know, all the water wasted on swabbing these millions of gallons around the world a day are wasted on swabbing pipelines. So what we said, well, let's go back to the basics then. We give you the cable, you pull a section together, and you pull the cable through. Now, we're winning work around the world now on the cable and the system approach that way. They build the cable in the pipe, you know, pressure test it. The client is told that we're going to survey the pipe afterwards. So they've got quality control in place already. We're independent. We'll say, well, we'll check the internal condition. We'll check the joints are hosed correctly. We'll check with acoustics for leakage. We'll check for trapped air pockets. So all this data, we'll say, we'll pass this pipe's clean bill of health. They'll do its pressure test. They'll chlorinate the same water. So there's a huge, you know, environmental impact on one system alone, you know, with the camera and the pipe pod system in there. So.
Fantastic. Thank you, Fabio. And I can see questions coming in already on these. We'll come back in the Q&A session.